I forgot to mention, make sure I always say out loud, I'm starting the recording. Don't let me get going and I haven't. All right, listen carefully. Lab 2 is Introduction to Science, Writing and Testing Hypothesis. So it's not a difficult lab. I mean, it basically walks you through what you're supposed to do. Just make sure you're answering every question that's in the lab. I call it the SALT lab myself, but okay. But it tells you the objectives, explain the role of each of the following in science, alternative explanations, conclusions, accept or and have to conclusions which have to do with accepting or rejecting the hypothesis, observations, predictions, test of experiment, theory, everyday scientific, how to write a hypothesis according to the format described, and then using electronic balance correctly. And it just shows you pictures on that there. But okay, it wasn't going to move. So it says the main task you face in this lab is to be creative while staying inside the allowed parameters, and your main obstacle is to move beyond assuming that there is just one possible solution to a problem. What it gets at is that when you're formulating a hypothesis, when you're making that educated guess, unlike figures that are shown to you, it's often more than one hypothesis that's being formulated. In other words, it's often one educated guess. Okay. If what you observed leads to a question that could have more than one answer. In other words, some people come up with questions, that have to do with what they observe that are not simple questions. So you can derive more than one hypothesis. And then from there, if you have the means, you'll test each of them. If you don't have the means, you try to choose the one that you feel is the most worthwhile to test. And that actually came from a scientist who won the Nobel Peace Prize. Cooper was his last name. He said that the group he was working with, they reached a fork in the road. Good science always leads to more observations, questions, and further hypothesis. And he said they had formulated two, and they were like, man, these are good, both of them. But we only have the means to investigate one of the two. And then he put his hands up, kind of like, well, we got lucky. We went the right way and we won a prize. So, but no prizes here other than a grade. So if you look here, you may require more than one experiment to prove if the hypothesis is true or false. Normally when you test your hypothesis, okay, you put everything down, as we said, you observe, you question what you observe, and then you take an educated guess answering your question. That's the hypothesis. Then what you do is you test your hypothesis. On paper, you design, you create or come up with a series of experiments to prove your hypothesis true. Then you actually conduct those experiments and collect the data. In other words, collect the results. But often the way it works is you have to duplicate those experiments. You have to show that your data's part of the way you show your data is accurate, okay, reliable, is through precision. In other words, can you duplicate these results over and over again? So often you'll have to do it more than once. In this lab, fortunately, you don't really do that. They just tell you, hey, if you set up a few experiments. And when you run these experiments and you duplicate them, you have to understand there are variables that can influence the results of one experiment to the next. Human error being number one. We're all human, and no matter how careful we are, if we try to do something more than once, there's a chance there's going to be variation. If you're somebody that likes to say cook, you might have likes to experiment, but especially or just follow a recipe, especially when you're following a recipe. The meal you cook up, you follow the recipe, might have come out great 2 times, and then the third time something went wrong. You don't know if it had to do with something you weren't paying attention to. Maybe you changed an ingredient, but it was supposed to be still the same ingredient, just a different company. So this is what we mean by variables. So whenever we would conduct research, okay, we had to pay attention to not just human error, okay, but the supplies using, the equipment we were using, and we got to the point we were superstitious, okay. We had to, the equipment and the supplies we were using, it had to be the same ones over and over, and sometimes it leads to a little fighting. So then it's going to tell you, it's going to talk to you about everyday problem solving, such as you and your friends are in your car, and it's going to give you a scenario. Okay, make sure you fill in the answers here, and I'm not going to go into detail because it tells you in the lab. Read through it, and then just fill in the boxes that are there as far as explanation and a test that might explain it. I test to prove if my explanation is correct. And then there would be a part where you would actually conduct an experiment. Like I said, I call it SALT lab because these figures are showing you what you would have done if we were in person. You would have taken a certain volume of water. Well, in the lab, we actually don't tell you how much water to really put. We don't give you measurements. We leave that up to y'all. We still know what the results should be, but every once in a while we get something completely different, okay? But what says, hey, add water to a beaker and then add salt to the point of saturation. Not every student understands what saturation means, okay? So not only is there differences in water that each group will add, but there's differences in salt. But they're showing you here, hey, look, we're adding salt to this beaker of water, and then they mix it up to dissolve the salt, and they keep adding salt until there's until the salt no longer dissolves, until you can see crystals of salt collect at the bottom. That's saturation. And then what you would be told is to add food coloring, but we don't give you a volume for that either. We leave that up to you. Okay, and then they show you what the expected result should be and so on. And then from there, that first setup that you do, okay, where you add the water, then you add the salt to the point of saturation, then you add the food color, and then you stir it all up to dissolve the salt. That's how you know when you've reached the point of saturation, when no more salt will dissolve. That's what we mean by saturation. And then you have to interpret your results, okay, based on what you think. So this is where some of that freedom comes in. I mean, granted, there's parameters, but it's based on your interpretation, and there'll be some of these pics in the docs that I posted. Then it'll talk to you about, hey, look, take some of this information and transfer it to a table. Across the top of the table are the different experiments they'll ask you to set up. Down the left column here is where you'll put your hypothesis. They give you one, and then they're going to give you a couple of others that you're going to have to write in. And then for each experiment, you're going to put down what the result was, is basically what you're recording here, okay? And based on that data, you're going to have another table, okay? And it's going to ask you, did you observe these results? And you'll put down whether you did or didn't. And then in the end, what you're going to end up doing is basically saying which of these three hypotheses that were formulated, and technically they're giving them to you, but you can figure them out for yourself what's going to happen if you read through it thoroughly, which of these three hypotheses turned out to be true based on the results of the different experiments you set up, okay, and what you observed in the results. Okay, so it's a very straightforward lab. Again, you can redraw the tables and insert the data on a separate document, or you can just type it into the doc and then submit the whole doc, or you can print off the doc, fill out everything in the doc, and if there's room to put everything in there, and then you can scan it and submit it, okay? But do make sure you answer any and every question that's in the lab, best of your ability. And it's easy points if you're just willing to put in the time. Okay, yes, Salt Lab's not the most exciting, although in person, it usually leads to a lot of discussion. But are there any questions about this? The hypotheses, when you read through it, they should be giving them to you for the most part, okay? No, you don't conduct the experiment. They're going to give you everything, and there should be figures in there. You can if you want, if you already have everything, but I don't want anybody going out to buy anything, okay? Instead of a beaker, just a glass. If you have salt and water and food coloring, you can do it at home if you want. It's up to you. Yeah, I'm glad. Thank you, Jessica, for asking that. Yeah. Okay. Sabetha, did I answer your question also? Okay. So it should be in there. Read it out. And if you have any questions, if you feel like, hey, it's not stating something clearly to me, just let me know. Okay. Just send me an email. And like I said, if you're willing just to put in the time and take the time, yeah, hopefully it'll go pretty smoothly. I hope. Of course, I had trouble getting into this session, so who knows? And I posted the wrong doc, so never mind what I said. Okay, I'm gonna stop the recording.